So, hello everyone. Let us discuss the solutions of the Codeforces round 1068. So, first of all, let us go through the question number one. That is quite a straightforward question, typical 800 rated type of question. What does the question say? That sleeping through classes, which means that there is a person who has to attend a class if the string value is equals to 1, and he can miss the class if string value is not equals to 1. Okay. But there is a constraint that for the given value of k, if there is an important class, he has to attend the remaining classes also. Okay, first let's look at the test case one, simpler test case. 4, 1 and 4, 1 and 1, 0, 0, 1. The k value is 1 here. So you can see that if he attends the class 1, he has to attend the class 2 also. But he can slip into this class, means he can skip it, so the answer is 1 here. Let's look into a bigger test case. 8201000101. The value of k is 2. Obviously there is no constraint in this 0, so he can slip in this class, but there is a constraint in this one, means he has to skip the other two classes, so he will skip that. Then he will slip into this class. He have to attend this class and the other two classes also. So he can skip this class and this class. So the answer of this test case is 2. So that's what asked in this question. Due to my foolishness, I have done two wrong submission. Like first of all, I was doing some approach like I was doing nested loop. Okay, whenever I find a one now, then I thought that let's skip the two indexes, but I forgot that in these two indexes there could be another one which makes the value of kk equals to k again. So that is what wrong in my this approach. So let us discuss the correct approach. Right. In this, what I have did, I have taken a temp variable which is equals to -101, and then here I have taken a very negative integer so that this value always comes out positive if there is any zero in the beginning part of the string, right? So I have stored I have stored I into my temp variable and then checked whether this zero is allowed to take in or not. If it is allowed, I have added into my answer variable, and at the end I have printed my answer. So that is the first question approach. It's quite straightforward question, nothing much to do. So now let us discuss the question number two. In this question, what it is asked that Nico is playing a game in which her initial score is 0, and she has to choose a card, red card and a blue card. Her score become k minus ai, where k is her score before the turn. Basically, if she chooses a red card now, then ai value will be subtracted from her current value, and if he su- and if she chooses a blue card, then its real value will be subtracted from the uh, index value of the blue card. Okay. So after this game, we have to calculate the maximum possible score Nico can obtain at the end of the game. Good, it is typically 1100 rated kind of a problem. What is, first of all, I thought that it is a DP problem, that we have to take all the cases like red, blue, all the uh, permutation, and then by using DP we have to solve this. But we can solve this using the greedy approach also. That's what I have done. I have did. Okay, so what the red card is doing now? Red card has the potential to make the minimum current score to maximum. Okay, what the approach I have thought that the red card has the potential to make the minimum. Sorry, the blue card. Actually, both the card have the potential to make the minimum value to its maximum. It depends upon the value of. It depends upon the current value and the card index value. Okay, suppose the current score of K is 0 and there is a value that is the minimum score we have so far. Okay, and suppose AI has a very large negative value, suppose minus 10 to the power 9. So, so it can make the current score positive 10 to the power 9. Okay. So what we have to do in this question now, we have to take two variable. One will store the maximum current score and one will store the minimum current score. And there are two operation we can perform. And what we will do is in one key we will do the two operation, in another key we will do the two operation. And after doing these two operation we will store the maximum in one variable and minimum in another variable, and at the end we will print the maximum value. That's what asked in this question. First of all, let us see my approach. Okay, in this I haven't even run the test case. I just thought like we have to do uh, this only. First of all, I was thinking of some DP solution, but it will be memory limit exceeded because the maximum value of target can go as far as 10 to the power 14, you know. So 10 to the power 14 into n size can lead to memory limit exceeded. So I didn't did the DP approach, and then I thought first, and then I take the input variable. After that, I took the two data type K1 and K2 as int, and in K1, and what I did in K1 I did the one operation with red card, and then another operation with blue card with K1, and with K2 I did one operation with the red card and the one operation with the blue card, and then in K1 I stored the maximum of all operation, and in K2 I stored the minimum of all operation, and at the end I print the maximum value among K1 and K2. It will always be K1, so we don't need this last line. We can simply print K1. That will also give the same answer. So this is my approach of question number 2 of the Codeforces round 1068. It is a quite easy type of question, means nothing much to think. And this is the question number C. First of all, let us go back. Let's come from here. And what this question say, it is also a typical 1300 type of a question, right? And in this question, it is given that you are given initially a value of n and k, and it is also given that it is given that where AI lies between 1 to k. Okay, AI lies between 1 to k, and we have to form a set B. Okay, then what are the criterias of this set B, right? Okay, we have to actually I solved here because I didn't look at this constraint, and I have did something like this which is of no use, right? Because it is already given that the maximum value of AI is k, so we have no need of this operation, but I didn't see in the question earlier. No, no, no problem, it still got accepted. So what is given that we have to construct a set B, okay, which is from B1 to Bm, and like AI also every value of Bi lies in 1 to k. We call it complete if it satisfies the following condition. Okay. What are the condition that at least one divisor of Bi is contained in B. Okay. Like and let's first of all read the second point. And for each I, for each j, that j represent the index from the set B, all positive multiples of bj which are less than or equal to k appear in the array at least once. Okay, like it like for every value of bj, it must be present in ai all the positive multiple which are less than or equals to k. Which simple meaning is that there will be a value of k which is given to you, and for all values of k there should be a positive multiple of bj. Okay, like if the k value is given you as 11, then bj is given you as 2. Okay, then in the set a 2, 4, 6, 8, and 10 should be present. If 12 can't be present because it is given that ai is less than equals to k, and the value of k is given out to as 11. So yeah, so first of all let us see the test case 1. In this test case it is given that 4 6 3 2 4 6. So first of all let us try to sort the given array. So after sorting the given array, the array will become as 2 3 4 6. Okay, so after sorting 2 3 4 6, array will become, and after that, first of all, see, it is given that we have to add the divisor. Okay, suppose we took the GCD, suppose there is a question that in this we took the GCD of all the number. Okay, suppose 10, 15, 20, 25 is given, and we added the divisor of all the number, and since all the number is divisible by 5, all the number is divisible by 5, so we added 5 into the set B. Okay, since the first condition is satisfied that at least one divisor of ai is contained in B, but it destroyed the second condition that all positive multiple of bj should lie in the array at least once. If we add 5 in the array B, then what will happen that there will be no multiple of 5 will be present in array 1. Okay, so we cannot add 5 in the array B. Okay, so actually what we have to do in this question that we have to add the element itself into the array B, and we just need to check that whether all the multiples of the adding element in the array B are present in the array A or not, which are less than or equals to k. Uh, Listen again what I am saying. Suppose 2 4 3 6. Okay, right now the set B is empty and the value of k is 6. So first of all we have to add 2. If we don't add 2 means there should be at least one divisor of 2, right? So we will add 2. Okay, after that we will check that in the range 1 to k, that whether all the elements of ai which are divisible by 2 are present or not. So 2 is present, 4 is present, 6 is present. So all the multiples of 2 is present in the set A. So the condition of 2 is satisfied. We don't have to add 4 and 6 because their condition is satisfied that there is a divisor present in the set B and all the multiples of the given divisor are present in the set 2. So now we don't have to do anything with 2, 4 and 6. What is given as 3? Since 2 is not a divisor of 3, so we will have to add 3 into the set B. After adding 3 into the set B, we will have to check that whether all the multiples of 3 are present in the set A or not, which are less than or equal to K. So we can see that 3 and 6 are present in the set K. So the set B formation is possible, and hence the answer is 2, 2, 3. Just look at this test case number 3, 36236. In this test case, the value 4 is not present in the array A, which contradict the first thing that the all multiples of 2 which are less than or equal to k should be present in the array A. That's not the case in this test case, which means 4 is not present in this array. Hence, there won't be any value of B satisfying the given set B condition. So there will be no value of set B formation, and hence its value is equals to -1. Just also remember that every that we have to construct the minimum size of the B. Okay, so it's a straightforward type of question, see this test case 5 5 1 2 3 4 5. First of all, we will add A because set B can't be. First of all, we will add the smallest element of set A. So we will add 1, okay, and check that whether every multiple of 1 is present in set A or not, which are less than or equal to k. You can see that 1, 2, 3, 4, 5, every element is present. Hence the condition is satisfied that at least one divisor of A is present in the set B, and every multiple of B is present in the set A. Hence, we don't need to add any element in the set B. We will only add element in the set B until or unless there will be at least one element whose divisor is not present in the set B. Like in the example 1, we added 3 into the set B because 3 divisor is not present in the set B, as 2 is not a divisor of 3. When we added 2, these three conditions got satisfied. But since the divisor of 3 is not present, so we would have to add 3 into our answer also. So that's what this question says. Okay, uh, let us look into the code. Okay, so first of all, what I did, I have formed a map. Okay, and this map stores the count of the every element present. Okay, after this we have form a temporary map is equals to m, just to the check, because here you will understand later what is the purpose of this map. Then first we will obviously sort, because the smallest element will always be present in the set B. That's the obvious condition of this question. And I have just showed you that I haven't seen that the maximum value of A can be less than or equals to k. So due to my foolishness, I add this. There is no need of this. We can directly assume max c is equals to k. And then we have formed the answer vector, which will store our answer. And then bool, you will realize its value later. And then what I did, since a first element will come, it will obviously be stored in AI. And then what I did, we I have taken x is equals to 1, and then did x plus plus, which will store the every multiple of x present in the array A, and which are also the multiple of AI. Okay, so if the given array is not present, means Less than 1 signifies that it is equals to 0. So if the given multiple is not present, like we see in the test case number 3, that it was 2, 3, and 6, and the multiple of 2, which is equals to 4, is not present in the array. So we will just to check is equals to 1, and we will break out from the loop, and here also break out from the loop, and we will print -1. If it is present, we will mark all the m of answer into x is equals to 0, लाइक कि भैया आपका जॉब खत्म हो चुका है, अब आपका जॉब इस वाले एरे में कुछ नहीं है। ठीक है, आपके आपका एक एक जो है डिवाइजर वो आपका वो सेट बी में आ चुका है। ओके, लाइक सो आफ्टर दैट what I why I have taken here like see, if like the LCM of 2 and 3, okay, since 6 is a multiple of both 2 and 3, so if here I would do m of answer into x, so for 3 6 is seems to be absent because here I have done that it is equals to 0, so 6 appears to be absent for the case of 3, so it will print answer as -1, but that's what we don't want. We want that it should be present and we can check its presence. So that's why I have formed a temporary map also. Okay, so we will do for the every element, and if every element multiple is present in the given array, we would, it's okay, and we would add into the temporary variable, and at last it is said that print the size of the temporary variable and print all the elements present inside the temporary element tem- temporary array. So that's what we did here. So it was a decent type of a question, typical 1300 type. So yeah, so that's all from my side today. I hope I could able to make you understand all the three problem of this code forces round. So yeah, thank you.